Hi friends, and welcome to another episode of Max Electronics. In today's episode we will be looking at a interestingly deleted, I guess, smart bulbs. And the part we're going to be looking at is the smart part of it, not the LED part. I'll leave the LED part to Big Clive to do, and we'll look at the smart part and how we can repurpose those. So those were at the local hardware store, discounted from $18.15 to $4. So I thought I'll get 3 of them just to pull it apart. And let's get started. So the bulb, by the way, is dual, so it can be warm or cold or in between. Dimmable, app dimmable. So obviously the app can do the scheduled timer. It's Wi-Fi connected, on off, and no hub required. So the standard type of so this is Arlic brand. The Grid Connect is actually by Data, I believe. The app that we use, the Arlic, is a pretty popular brand in Australia here. So we've got a bulb here. It's a B22, a Grid Connect. It's 9.5 watts, 75 milliamps, standard. So it's 806 lumens max. That's plastic, so be careful when you're opening those with the glass. You don't want to shatter you don't want to shatter it in your hand. So those usually, oh yeah, you can see it's popping out. Just standard silicone in there. There we go. Oh, interesting. So we can see the LEDs. You can see the warm whites and cold whites. They just slightly different tint to them. So the LEDs can be unplugged. I just need to scrape off that silicone from around here. And that thing's supposed to pop out. I'll show it to you working, but I just don't have any B22 handy at the moment. Still haven't unpacked those. Usually use an adapter between the E27 and B22 socket. But I've got E27s, but not B22, so we'll have to just hardwire it, I guess. That's a Wi-Fi module sticking out here. I've scraped off all the silicone around, and that's pretty loose, so we can pop this off now easily, supposedly. There we go. There we go. So that's the standard LEDs with warm white or cold white, and we've got our main circuitry in there. So I'm going to, that looks like your Wemos D1 ESP module, so I'm going to pop this off and get it out of there. 1 and 2, and the whole circuitry comes out. So we're going to convert it to normal LED bulb. Looks like it's got 2 switch mode power supplies. Oh, no, this is an inductor. And very interesting circuitry. So let me zoom in for you. Here we go. That looks like a MOSFET, I'm assuming, that you can see is driving to the LEDs. Well, it's going to the LEDs straight away. And that what looks like a power supply for it, I'm assuming. We'll have to trace it out. That would be the switch mod power supply. Interesting. And yeah. I'm going to desolder this part, and we'll have a look at it closely and where the tracks go. So far I can see only 1, 2, 3, 4, 5 connections that are connected to this module, and I assume it would be a voltage supply, positive, negative, and another 3, I guess, output, maybe. All right, let me remove that and trace things out, and I will draw a basic schematic to see where things go. I have explored it further, and what we see is there are 3 chips. I'm still not sure the other one. I couldn't find the datasheet, but it looks like it's a switch mode power supply chip. Probably to supply the power for the little, I guess, ESP module. I don't know, it doesn't say. I think it's a proprietary one because when I remove the sticker, there is nothing underneath it. And what happens is we've got 2 chips. One of them is for PWM dimmable buck LED driver, which is a BP2876D. And the circuitry is pretty simple. You've got the AC coming in, you've got your bulk capacitor, you've got the chip itself with a PWM input and the LED driver, LED itself. Then we've got the 3.3 volts output as a PWM to dim it up and down, varying the duty cycle. For this one is your color selector chip, and it is there was a somewhere description I saw, so it's a LED driver for the dual color. Very similar to it. You've got the LEDs of 2 colors that's going to the chip, again powered by AC bulk capacitor, and it's got PWM color. So when the duty cycle is set 100%, you would get the warm white. If the duty cycle is at 0%, you would get a cold white. Apparently works at 10 kilohertz. And the pins on that little device that I've desoldered, it looks like a standard ESP module. I'll zoom in a second. We've got 5 pins engaged. 2 pins for power, so we've got ground and we've got VCC 3.3 volts. We've got 1 pin enable, so it connects enable pin via the 240 ohm resistor to VCC. And then we've got 2 pins outputs. We've got pin 05, which is a dimmer, and pin 13, which is a color selector. I'm very curious if I connect, let's say, to the chip. So the dimmer is obviously easy one because it's already programmed in the app. So if I'm repurposing the chip, you know, I would have an option of having a dimmer, an option of having a warm and cold color. So the dimmer stays the same, but for the color, I'm thinking, what if I have the pin 05? Let's say this is side of a device. This is pin 05. And I would connect 1 LED just for testing, positive, via the resistor to ground, and the second LED as negative via the resistor to supply. Obviously using a MOSFET. Will that change them? So if a duty cycle is at 100%, this LED will light up, and if duty cycle at 0%, this LED will light up. We'll experiment with that. So let's zoom in into the chip. Here it is. As you can see, it looks like a standard ESP, but it's not. It's TYWE3L. Very interesting. Okay, let's have a look now at the very safe circuitry that I've got here. What I have done is this blue wire short circuits the 3.3 volts to the dimmer, so this will turn the light on. And those 2 probes are set to the milliamps current measurement through the multimeter, just for the purpose of short circuiting things. Now let's turn this on. And as you can see, because the dimmer, we've got a warm white at the moment, and you can see the dimmer is on. If I cut the blue wire, it'll turn off. So now I'm going to short circuit the 3.3 volts to, well, through that. As you can see, I'm touching it and it's already changing the color at the duty cycle. But if I short circuit to the 3 volts, as you can see, it goes cold white. So warm white, cold white. And if I just touch 1 pin to this, it lights up slightly the other LEDs as well. I know it's probably hard for you to see the other LEDs, and if I point it at the camera, it'll swamp it out, but we will try anyway. I will try So let's see if I can just partially light up the other LEDs. All right. You can just see them light up. So for the purpose of repurposing the light as well, it's fairly right. For the purpose of repurposing the light, I'm going to think of some way of maybe adding a little 555 timer to get it PWM onto the pin, so it'll light up the entire. I could just leave it like this with those two pins shorted and put it back together and I'll have a warm white light. But, or, yeah, that's a good one. So if I want to light up all LEDs, I will have to have something like a 555 timer doing the pulse width modulation on that pin 5. Or I could have a little switch where I can select between the warm and cold color simply by shorting the two pins together or breaking them apart. That's a tough one. I don't really use the bulbs at home. I've got LED strips everywhere as a lighting, so I don't know. I've decided to experiment a little bit, and I have added a 1 meg ohm resistor between the pin 5, which is the color selector, and the live directly. So it will pulse at 60 Hertz, and it works. The only thing is a bit flickery, so let me show you. We've got full color. I don't know, you can't see on the camera, but all LEDs are lit up, as you can see. And yeah, with the shutter speed, you can just see them. Oh. Yeah, you can see the shutter scanning, but all LEDs lit up at 50 Hertz. They are noticeably flickery, but well, it's not that bad, I guess. It's usable, but it's brighter, so that makes the bulb a lot brighter than normal. Okay, so I have set up the little Wi-Fi module just to hook up to the scope so we can see what's happening. And I've got the first channel, which is yellow, hooked up. Let's bring the scope up to the screen. The yellow is hooked up to the dimmer, and the blue is hooked up to the white balance. I've also got the app right here. Let me just boost the brightness. It's already paired with the app. So let's have a look at the scope. If I turn it on now, note that the dimmer is set to low and the white balance, I guess, set to white, pure white. So I turn it on, and you can see on the scope we've got the trace of the PWM. Let me just get that menu out. There we go. And it's at 1 kilohertz. So let's increase the dimmer and see what happens. And as you can see, as I'm increasing it, and that would be the full. So we'll leave it at 50% or around there. That would be 50 right here. So that's exactly 50%. And now let's do the white balance between the white and warm white. So at the moment it's set to white. And now I'm just slowly going to warm white. And there we go, that's warm white. And let's set it to 50% around here. I think I may need to calibrate the probe. You can see the bit of a rough edges there. There we go. So, and then again, the dimmer will just dim it, but the color balance will stay the same. Okay, now that we've done this, let me quickly do a quick breadboard with a couple of MOSFETs, and we'll hook it up and see if I can get the negative and positive MOSFET hooked up to the balance pin, and we can change then the color this way. I've set up a little breadboard here just to demonstrate what happens. So at the moment it's switched off in the app. Let me just get the app here on the screen as well. So this is the muster is off. And as you can see, I might actually turn this light away as well. The color changing one between the white and warm white and cold white, they're always pulsing. So at the moment we've got the green one. I've set it as green and red, and the blue one represents the dimmer. So if I turn it on here, as you can see, the blue one turned on, and I can dim it. Very smooth dimming. And now I can control the white balance by sliding this, as you can see, go between red and green. So this is hooked up directly as I have drawn before, right here. So that's how I hooked it up. So that pin, just two reverse diodes. One goes to positive, one goes to negative. And this is how I'm changing them. So that can be totally repurposed to do anything with that controller. And the thing is, it's genuine, so you know there's no glitches. That's on it. I know you can download the code for the ESP modules and do it yourself and download some sort of a dodgy app that may work or may not work. And yeah, but this is a genuine hourly product, so I can figure out to do something with it, maybe some sort of a light or yeah. But that's it. Thanks for watching. I hope you enjoyed this video. By the way, the app's got like tons of features. It's got schedule or countdown. There's a plenty of interesting stuff on there. So yeah, don't forget to share, like, and subscribe. I will be back with a new video very soon. I've got a few projects that we will be doing together. I will see you next time. My name is Max. Bye.